Hello students, in this video we will be reviewing the lesson 2-6 equations of parallel and perpendicular lines. This is a continuation of yesterday's lesson, so we're going to go ahead and begin by completing the do now. It says, determine if the given lines are parallel, perpendicular, or neither. The first thing that you have to recall here is that if lines are parallel, then lines will be having the exactly same slope. When lines are perpendicular, then lines will be having opposite reciprocal slopes. So when the lines are neither perpendicular or parallel, then the lines are not going to be having the same slope, or they will not be having opposite reciprocal slopes. So they're just going to be having different numbers. So look at the first problem. Find the slope of AB for A is 3.5 and B is located at -2.7. So the first thing that you have to do here is calculate the slope, but since you're giving two order pairs, you will be using the slope formula to find that slope. y2 minus y1 over x2 minus x1. Let's label the points, x and y, x and y. This is my first point and this is my second point. Once you finish labeling them, then you need to come back and substitute. This is 7 minus 5 over -2 minus 3. 7 minus 5 will give me 2. -2 minus 3 will give me -5. And this is the slope for the line AB. We do the exactly same thing, but now for line CD, recall the formula of the slope, y2 minus y1 over x2 minus x1. Come back and substitute. Come back and label. And substitute 15 minus 5 and 6 minus 10. 15 minus 5 is 10. 6 minus 4 is negative. 6 minus 10 is -4. I'm already thinking about the answer. Super important, guys. When you're dealing with fractions, when you're dealing with ratios, you must simplify them. So you got to simplify by dividing by 2, numerator and denominator. So this is going to give us 5 over -2. All right, now for the last step, we got to determine whether the lines are parallel, perpendicular, or neither. If they're parallel, that means that the lines will never intersect, and they're going to have the exactly same steepness, so they have the same slope. For this particular problem, -2 is not the same as -5/2, so these lines are not parallel. For perpendicular lines, we know that perpendicular lines are going to be lines that are going to intersect, forming a 90-degree angle. And because they're going to intersect, they're going to meet at a 90-degree angle, then these lines need to have opposite reciprocal slopes. Notice that 2/5 is the reciprocal of 5/2, but because both fractions are negative, they're not opposite. In order for these to be opposite reciprocals, then one fraction must have been positive and the other one needs to be negative. So these are not perpendicular. So our final answer is neither. But what does neither mean? Well, neither just means that these are going to be two lines with two negative slopes that they will meet. However, they're not going to be forming a 90-degree angle when they meet. So those are a type of neither parallel, neither perpendicular lines. All right, let's continue. The objective for today, student will be able to determine if the lines are parallel, perpendicular, or neither by rewriting the equations from standard form to slope-intercept form. Okay, so this is again a continuation of the lesson yesterday. And I just want to review a couple of points with you guys before we start on the practice problems. So slope-intercept form. Slope-intercept form is our favorite one, right? Because when we have the slope-intercept form, it's easy to identify the slope and to identify the y-intercept. And that's why these type of forms, equations, are going to be very easy for us to graph. So again, I just want to make sure that you understand M stands for the slope and B stands for the y-intercept. So in this one, you have here a graph, and they're asking you to write down the equation of this graph. So there's two important parts that you need to identify. The first one is the slope. And the second thing that you need to identify is the y-intercept. So for the slope, we know that because we're given a graph, we don't use the slope formula, we use the rise over run. So to find the slope, you just gotta find 2 nice points on the graph. And you gotta count how many units am I rising. In this case, I'm rising 1. And I'm running 1, 2, 3, 4. So my slope is 1/4. Now my y-intercept, that's where the point in which that given line is intersecting the y-axis is at -3. So then all that you have to do here is rewrite the equation with the given slope that you found and the y-intercept. So this is y equals 1/4 of x minus 3. Right there. Okay? So the slope is 1/4, the y-intercept is -3, and this is called slope-intercept form. The name says it, slope-intercept form. The next thing that I'm going to be reviewing is the standard form, ax plus by equals c. Because standard form doesn't give you the slope, you always have to change it back to slope-intercept form so that you're able to identify the slope. And from there, whatever the question is asking you, determine if the lines are parallel, perpendicular, or neither. It's super important that you guys understand that A cannot be negative. Okay, another thing that you need to understand is that A and B cannot be 0. Okay, but you know that A, B, and C are integers. Okay, make sure that you keep that in mind when you're writing the standard form. Now, looking at this standard form, right? This equation that is given to us in standard form, 5x plus 2y equals -2. We need to change this from standard form to slope-intercept form. So we need to make sure that we solve for y. And there's 2 simple steps that you have to follow in order for you to solve for y. The first step is to cancel the x term. So I got to cancel that 5x so that I can leave y alone. So I got to do that by doing the inverse operation, -5x. And what I do to the left side, I do it to the right side of my equal sign because this is an equation and I got to maintain the balance of it. So this is going to give us 2y equals -5x minus 2. Again, our goal is to solve for y. So now I got to cancel that coefficient 2. I do that by applying the inverse operation. I know that 2 and y are multiplying right now. So the inverse operation of multiplication is division. So this is y equals -5/2 of x. And then -2 divided by 2 is going to be -1. So now it's very easy for me to see the y-intercept as well as to identify the slope of this line. The slope of this line was -5/2 and the y-intercept was -1. I also want to make sure that we review what vertical lines look like and what the equation of a vertical line will be. Vertical lines will be on the equation, they would have the equation x equals a, where a represents the line's x-intercept. So for example, guys, if I give you x equals 7, I know that this line will be intersecting at 7 on the x-intercept. So x-intercept on the x-axis, I'm sorry. So we're gonna count 7, like about right here. So I'm gonna draw a vertical line right there. I'm gonna give you another example. If I tell you x equals -2, I gotta go on the x-axis and plot my x-intercept, -2, and then I gotta draw my vertical line. Just like that. Now for horizontal lines, the equation of horizontal lines will be y equals a, where a represents the line's y-intercept. So same thing, kiddos. So for example, if I have y equals 2, I'm going to go on the y-axis and I'm going to plot the point at the 2 on the y-axis. And then I'm going to draw my horizontal line. Okay? So if I give you another example, y equals negative 3. I go on the y-axis, negative 3, right here, and I'm going to be, that's for that one. I forgot to change the color. But that's going to be my horizontal line for the equation y equals negative 3. They were giving you two examples here. So like example, that one, that line right there. We know that that line is y equals, I'm sorry, not y equals, it's a vertical line, x equals negative 1. And then for the next one that they were giving you here is y equals negative positive 3. Positive 3. Quick reminder, you should already know that. I sound like a broken record, but parallel lines, make sure that you know these, that they don't intersect and they will be having the same slope because they have the same steepness. Perpendicular lines are going to be having two lines that are going to be intersecting at a 90-degree angle. So make sure you indicate that box for the 90-degree angle. And their slopes are opposite reciprocals. Super important for neither parallel, neither perpendicular. Those are going to be just intersecting lines. And what that means is just going to be two lines that are going to meet, but the angle is not 90. It could be anything, okay? So those are examples of intersecting lines. Let's go ahead and review some problems. So just a quick summary. To determine if lines are parallel or perpendicular, write the lines in, very good, slope-intercept form, which is y equals mx plus b. So when we are giving an equation in standard form, we gotta solve for y so that we can have it in slope-intercept form. After that, you have to identify the slope in both equations. If they are the same, then the lines are parallel. If the slopes are opposite reciprocal, then the lines will be perpendicular. Super important, guys. Super important. I'm giving you also instructions on the independent practice with the steps that you need to follow in order for you to solve those 10 problems successfully. So let's go ahead and do this one. Determine whether the equations are parallel, perpendicular, or neither. So for the first problem, my equation, I gotta ask myself, is my equation in slope-intercept form? I know that it is because y is already by itself. Y is already by itself in the second equation as well. So I don't have to do anything here. All I gotta do is identify the slope, which is a coefficient of x. So for the first equation, my slope is 5. For my second equation, my slope is 5. So what do I notice? Since they have the same slope, then these lines will be parallel. As easy as that. Okay? Now on the next one. Same thing. The first thing I gotta make sure is that my equations are in slope-intercept form. And I know that they are because y is by itself and y is by itself. So all I gotta do here is identify the slope for the first equation, which is negative 3/2. Identify the slope for the second equation, which is 2/3. What do I notice here? I notice that the fractions are flipped. So that's the reciprocal. And I notice that one fraction is negative and the other one is positive. So because one is negative and the other one is positive, we have opposite reciprocals. And when we have opposite reciprocals, then we're going to be having perpendicular lines. As easy as that. Now notice on the next one, x plus 2y equals 2. That one is not in slope-intercept form because y is not by itself. So we need to change these. This is actually in standard form. We need to change it from standard form to slope-intercept form by solving for y. I told you there's two simple steps. Cancel the x term and then cancel the coefficient of y. So let's cancel the x term. So that's going to give me 2y equals negative x plus 2. And then cancel the coefficient of y by 2. So y equals negative 1/2 of x plus 1. For the next one, I notice the same thing. Y is not by itself. So I got to change it from standard to slope-intercept form by canceling the x term. Negative 3y equals, I know that negative 6x plus 21 has to be listed up horizontally, because they're not a like term. I don't want you guys to be putting 27x, or I'm not 27, I'm sorry, for you guys to be putting 15x, because that is not correct. They're not a like terms. So just list them horizontally. Second and last step, divide by the coefficient of y. Super important that you simplify. A negative 6 divided by a negative 3, negative 6 divided by a negative 3 is going to be a positive 2 over 1, or 2. But I want to keep it as a fraction because I need to be able to see if these are parallel, perpendicular, or neither. 21 divided by negative 3, that's going to give me negative 7. So once I already have my equations in y equals, then I can just simply identify the slope. The slope here is negative 1/2. The slope here is positive 2 over 1. And what do you notice? Are the lines parallel, perpendicular, or neither? Very good. The lines are going to be perpendicular. You got it. Hold on, because then I'm not perpendicular. I'm just going to put the upside down T, which is the symbol for perpendicular. Okay, because I don't want to go over the space of problem 4. Right on the next one. Same thing, guys. Y is not by itself. Okay, so we need to cancel the x term. Negative y equals negative x plus 9. And then we have a negative imaginary 1 there. So now we got to get rid of that coefficient. Y equals negative x minus the negative x, which is a positive negative 1 there. So negative 1 over negative 1 is positive 1 minus 9. Remember, the slope here is still a 1. A 1. Okay? And then notice that for the next one, y is already by itself. So all I got to do now is identify the slope. The slope here is 1. The slope here is an imaginary 1. I know there's an imaginary 1 there. So because slopes are the same, can you take a guess of what type of lines are we dealing with? Very good. These are parallel lines. All right, and the last ones, they're super easy, guys. Don't be discouraged when you see y equals a number or x equals a number. Remember, horizontal lines are y equals a. Vertical lines are x equals a. So right now I'm just gonna draw my I'm gonna draw my coordinate plane. I have y equals negative 7. I go to the y. On the y-axis, I go to the negative 7. So negative 7 is like about right here. And I draw a horizontal line. And then I have x equals 2. So I go on the x-axis, I go at 2. And I draw a vertical line. So what do you notice? When we have a horizontal and a vertical line, what do you notice here? Very good. These lines are going to meet at a 90-degree angle because of the direction of them, right? And both of these lines are going to be perpendicular. Excellent. Now for the next one, same thing. I encourage you guys to do the coordinate plane. Super easy. And I know that my first line is x equals 9. So I'm going to go on the x-axis at the 9. I'm going to pretend this is a 9. And you're going to put your vertical line. The next one is x equals negative 5. So on the x-axis, I go to negative 5, which is like about right here. And I draw my vertical line. So what do you notice about these lines? They're both vertical and they have the exactly same steepness. Okay, so because they're both vertical lines, they have undefined slopes, which is the same, right? So very good. What do you notice about these lines? That they're parallel. So that's what you're going to be expected to do for your independent practice. You have 10 problems. Okay, and they're on a form. And all that you have to do is like problems 1 through 6. You're going to determine if lines are parallel, perpendicular, or neither. Watch out because you're going to have some examples of neither. You just got to make sure that you check your signs, respect those negatives, and remember the rules for multiplication and division. When you divide a negative over a negative, it's a positive outcome. And when you have a negative over a positive, when they're different, they're going to be a negative. Your answer will be a negative, okay? So that's it for today, guys. I hope you find this video helpful. And if you have any questions, you can always reach out.